Hello, and thank you for joining us for this webinar on taking your USV to the next level. I'm Aidan Thorne. I'm the Marine Robotics Business Development Manager at Sonodyne, and I'm here today at the National Oceanography Centre with Malik Shiva and John Holder from our engineering team. As I say, we're at the National Oceanography Centre today, and we just thought this was a perfect setting to be for a webinar about marine robotics, as it's the home of Europe's largest fleet of marine robots. So we'd really like to thank the NOC for allowing us to do this here. We are, as you can probably tell, in a working environment, so there could be some distractions and noises throughout the session. So do please bear with us if anything like that happens. Also note that there is a Q&A box within the call today. We'd love to have your questions coming through. This sort of thing only works if there is a lot of interaction, so please do send your questions in, and there'll be opportunities throughout to answer those. But now I'm going to hand over to John, who's going to take you through the first section of the webinar.
That's great. Thanks, Aidan. So yeah, I'm going to be here today talking a bit about USVs and what we use USVs for, or what they're used for out in industry as well. So what do we think most people are doing with USVs at the moment? I think USVs in general, the majority use case for the last 5 or 10 years has really been multi-beam, traditional hydrographic survey, that kind of thing, maybe charting or for an oil and gas type projects. But what we're really seeing is that another emerging use case, which is towfish tracking, ROV tracking, UUV tracking, because we're finally starting to solve that problem of how you safely deploy and recover something on a USV. So towfish tracking things, I'll be talking a bit about what a range 2 USBL systems can do. And then for that multi-beam use case that I spoke about, Malik in a few minutes will talk about what we can do with our Sprint and family as well. Then there's another use case that I'll cover after that, which is data upload, which we do a lot of things with wave gliders, those kind of platforms. To just start off with, I'm going to start off with Ranger 2 and what Ranger 2 is. So Ranger 2 is a USBL platform. It's Sonodyne's USBL software and entire solution. So what Ranger 2 does, it's a really scalable tracking and communications solution. And it's scalable because the UI and the interface always stays the same, regardless of the transceiver and the accuracy that you select. So when we start off, we'll probably start off with our lower accuracy systems, such as Micro Ranger 2, which we kind of re-released this year in a really nice portable IP67 penny case. So that's a really rugged system for kind of AUV development programs, or for really small USVs as well. In terms of accuracy, because accuracy is a lot of what drives the decisions for these systems, we're looking at kind of between 3 and 5% as a system accuracy of slant range. So that's 3 or 5 meters of error possible over 100 meters of range. However, probably the biggest system that we see on the USVs, or not the biggest, sorry, the system that we use with USVs the most, is probably our Mini Ranger 2 system. So that uses this HBT 3000 transceiver. And that's the real workhorse of kind of offshore survey and lots of wind farm survey that we're seeing at the moment. Slant range wise, if you're using the internal IMU, the magnetic compass, that will give you between 1.2 and 1.3% of slant range. However, normally when people are kitting these to a USV, you'd be looking at about 0.2% or 0.1% of slant range if it's well calibrated and aligned to a high accuracy IMU, like you would have on a lot of kind of survey ROVs. If you want to go a step above the HBT 3000 and your USV is working in deep water, or you really need a pre-calibrated system, then you might want to look at something like our Range 2 Pro or Gyro USBL systems, which come completely pre-calibrated. And accuracy-wise, they're really class-leading at kind of down at that 0.04% of slant range. So that's the kind of Gyro USBL. But before we move on, let's have a quick recap of the array here. So this is a very similar array for the Mini Ranger 2 systems and the Gyro USBLs. Because it's a planar array, so all the elements are on this flat face here on the bottom. It's got really good noise blocking behind the array. And for USVs, that's great because that means you can have a slightly noisier USV. And also you can track at higher speeds because we're going to reject all that noise that's not coming from the areas that we're interested in. Right? So less noise, higher signal to noise ratio, ultimately better quality tracking. The other great thing about this HP 3000 is it's really compact, so you can go into quite shallow areas. And also it's very robust because it's not got any kind of dangling legs or anything that you might have in a volumetric array, which may be more prone to damage. So if you're lifting your USV in and out of the water, putting it on trailers, this is probably a slightly better system to be looking at. So that's kind of the USBL systems as a whole. In terms of tracking, we normally do tracking at Sonodyne. Simple tracking we would do with just tracking up to 10 groups of 10 transponders. So something like this nano here, you could set this up to track multiple beacons. The USBL would, of course, track the transponder. This nano here, we have a depth-aided transponder, really good for tracking at high elevation, because if you constrain the kind of azimuth or the angle with the USBL and you constrain the depth with the transponder, you've got a really nice high elevation solution. The other thing that we do that's great for USVs with Ranger 2 is remote control. So you can have your software running on the vessel, but you can have a completely remote wireless link controlling that Ranger 2 software. So we've got customers uploading sound velocity profiles, starting, stopping, tracking, all the core functionality of the USBL, but from the desk, not locally on the vessel. I'm going to be discussing a bit more about remote control in the kind of UUV session tomorrow. So do send any questions in today as well if you've got them. That's just simple tracking if you're just tracking an ROV or towfish deployed from the USV. But what if you want to start working with AUVs? Well, then you don't just want to know where it is, but you also want to know where that AUV is. You want to tell that AUV where it is, or at least tell the inertial navigation system on that AUV where it is. And you probably also want to communicate with that AUV, so sending data in both directions. So that's what you're interested in, then the robotics pack that we do at Sonodyne is probably the place to go. And that's really neat, because what it does is every time we track, we're obviously calculating the positions of all those towed objects or all those AUVs underneath the vessel, and then we're sending that down. I'm going to cover that a bit more tomorrow in the ROV AUV session, but very applicable to USV AUV use cases. The great thing also about that is that, yeah, because we're calculating that, we can send that position into a third-party INS. The robotics pack from Sonodyne is a really mature product. There's lots of really good videos on our YouTube and also on the website, and our applications team are really experienced at supporting it as well. So any questions, just send them over. So that's kind of a bit of an introduction to Ranger 2, which is of course the USBL solution. But what a lot of customers and people that we work with find is that they don't always want tracking. A lot of the time they just want the data. So Sonodyne have been working with kind of lower power USVs for many years. But typically that's Waveglider and Autonaut as well. And they're used for lots of data upload and genuinely over the horizon operations. So what we do with Waveglider is we make something called a Waveglider transceiver module. And we've been working in the Gulf of Mexico and many other areas with Waveglider for 5 to 10 years now, uploading multiple years of data on seabed deformation from around the globe, and doing that genuinely without any footprint offshore at all. So that's kind of Waveglider transceivers. We've been working with Exocean as well. So we did a really nice case study in kind of March or April last year, so right at the start of the COVID pandemic, where we had a scheduled data upload from the Ormen Lange field off the coast of Norway. And we sent a Exocean USV out with a HPT 3000 USBL on it. So that HPT 3000 is a dual function USBL and modem data upload. And over the course of about a few days, they sucked up all the data from hundreds of seabed logging beacons and sent it straight back to the client on shore in just a couple of hours. So that data upload is really reliable on something like a HPT 3000 because it's got the 5 elements on the base, so a really good, powerful modem upload tool, and really suited for being permanently mounted on the bottom of the USV as well. So before I move on completely from data and Wavegliders, there's something that personally I'm quite interested in. So there's a lot of discussion about what we've done with acoustics that are less publicized, and probably GPSA is the main one. So Sonodyne are in every major subsea fault zone, and we've got networks of transponders on the seabed. So what we're doing is we're monitoring for tectonic plate movement, subduction, that kind of thing. So normally what you'd have in a traditional Sonodyne LBL array is a transponder like this, but maybe a bit bigger, one of our fetch transponders or AMTs. And what they can do is they can autonomously log ranges. So you put one of these on one side of a subduction zone and one on another. And then what you can do is over time, to a centimetric level of accuracy, you can measure continuous baselines, which will monitor the seabed for movement. And that's really accurate. We've been doing that for years. However, what that does require is a lot of seabed infrastructure to calculate that LBL array and measure those baselines over time. So what a lot of people came to us and said was they want a lower effort, a simpler way of doing that. So what we can do now is you can put one of those same fetch or AMT transponders on the seabed, and Sonodyne or Waveglider will come along with this GPSA package on the Waveglider, And what that is the wave-guided transceiver, really high accuracy dual heading device. That's 2 GPSs, fore and aft on the wave glider, and a small IMU as well. And basically, because our acoustics can measure a range to a centimeter level of accuracy, and the GPS can be post-processed to in excess of that, that means that every 6 months or so, you can revisit just that one transponder on the seabed and know where in X, Y, and Z to centimeter levels of accuracy that transponder is in a real world frame. So you're monitoring seabed movement without a network of transponders with just one transponder. So I think that's a really nice, neat use case of a truly over the horizon USV. The other great thing is that because those fetchers and AMTs are down there, they can also be logging inclination, temperature, and sound velocity. And the USV comes along every now and then, sucks that data up and boxes it in as well. So that's a bit of GPSA, but I can see some questions coming in. So I think Aidan's going to come in and pose them to you.
Yeah, thanks for that. Yeah, there's a few questions coming in already, and do please keep them coming in throughout the webinar session. First question is, you've mentioned a few of the USVs that were on, and it may be useful to recap some of those, but also any others that were on as well.
Yep, sure thing. So we're on the X-Ocean USV with this H23000 for USBL tracking and data upload. The new Fugro Blue Essence USVs, we're on those. The mini range is a standard fit there. Ocean Infinity, which Malik will be talking about later, also using our kind of HVT USBLs. The Expo Drix, we put a mini ranger on recently. And of course, the HydroServe USV, which is just behind us over there. We're doing a lot of work with them at the moment, tracking and navigation, some really innovative projects.
Great, thanks, John. Question also about the HPT. HPT 3000 and HPT 5000, what's the difference?
3000 and 5000. In terms of array, the array aperture on a 5000 is slightly bigger. So it will get kind of slightly higher accuracies, especially over longer ranges and deeper water. You also got a higher source power level on a HPT 5000. So it's quite marginal differences, but it's the marginal differences that can drive that higher accuracy as you go slightly deeper and longer ranges.
Thank you. Just one more for John now, and then we will have another opportunity to talk to John later on in the session as well. So do please keep those questions coming in for him. But yeah, there's a question about the waveguide transceiver. Would it also work on and fit on an Ethernet?
So the waveguide transceiver itself is a fairly simple Sondyne transceiver in a payload. I'm not sure if it would drop straight into an Autonaut, but certainly the Sondyne hardware would go into an Autonaut, just maybe not in that drop-in payload. But yeah, if you're interested, we can certainly work something out.
Great, thanks, John. Yeah, as I say, do keep the questions coming in. So we'll have John again at the end of the session. We're going to hand over to Malik now.
Great, thanks, Aidan. Thanks, John. Hopefully that's given you an overview of some of the positioning and communication capabilities that we can provide for your USVs. And now I'm going to be talking about navigation and guidance for your USVs. And the products that we have available for that are our SprintNav family of hybrid acoustic inertial navigators. We've got a few different versions of those. Some of them are on display here, and I'll talk you through those in a moment. But all of our SprintNav family each contain and tightly integrate a high-performance inertial navigation system, a Doppler velocity log, and also a pressure sensor. And we tightly integrate all of those components into one combined instrument, not just at a mechanical level, but also at an algorithm level. And that provides some particular benefits over separate INS, DVL, or other combinations of sensors. In terms of navigation performance, it provides the best performance, and that's in terms of both the navigation accuracy and also the reliability of the navigation. For example, because we use each individual beam from the DVL into the INS solution, and they can be accepted and rejected on their own, it makes the navigation much more reliable and robust over challenging bottom lock conditions, for example. Also, tightly integrating these instruments together means that we can provide combined instruments that are much smaller in terms of size, weight, and power compared to separates, which is obviously going to be reduced cost and also reduce power and payload space on the USVs. So I guess the first question is why would you consider using something like a SprintNav on a USV like this RE40 from HydroServe? Well, A lot of these types of vehicles are used, for instance, for multi-beam survey in shallow waters. So if you think about some of the capability of a sprint nav and its ability to continue to provide navigation relative to the seabed, even if external position aiding like GNSS or GPS isn't available, there's some very good benefits there in being able to continue working even if you start to lose what is the more traditional and most widely used way of positioning these kinds of vehicles, which is GPS or GNSS. So across our Sprint Nav family, we have our full-size Sprint Nav and our smaller Sprint Nav Mini. I'll focus on some new additions to both groups of products, and we'll go through those. So we'll start with our full-size Sprint Nav Mini over here. So earlier this year, we launched the very highest performance version, which is Sprint Nav X. It really is about the highest performance you can go in a commercially available hybrid navigator. So to give you an idea of what it can do, we actually had a funded demonstrator courtesy of the Defence and Security Accelerator here in the UK. So we installed it on a C-kit USV, and we were running various simulated missions, again, without external aiding, no GPS, no GNSS. And we could demonstrate on a platform like that in normal seabed conditions, varying seabed types, a navigation error of just 1 meter without any external aiding over 10 kilometers. That's a pretty unprecedented level of performance on a real world platform in real time without external position aiding. So again, there's quite a lot of interest in that, and it really does open up the operating window of these type of platforms. So the other option we've got is a high altitude DVL option for our Sprint Nav family. So we now got the option of a 400 kilohertz DVL, which increases the maximum seabed altitude up to about 230 meters. And what that means is that a USV fitted with a Sprint Nav with this higher altitude option is going to be able to operate further from shore, but still benefit from that seabed relative navigation if it needs to. And a Sprint Nav in the full-size form factor is the perfect kind of instrument for demanding navigation applications for medium, large USVs, or potentially also autonomous shipping. There is more autonomous shipping coming up, and particularly in sort of shallow coastal areas, harbors, safe navigation is important, even if GPS is lost. So it's a very good fit for that kind of application. So moving across to our Sprint Nav Mini, and in particular our newly launched Sprint Nav Mini Navigator version, which we just launched a few days ago. So in terms of Sprint Nav Mini, it's obviously very, very small. It's just about 200 millimeters tall, very lightweight. This is the 300 meter version. This one has top connectors. We also have a side connector version. Again, very, very lightweight, very small. Low power, just 10 watts, which is about a third less than a separate INS and standalone DVL that could be considered. But in terms of performance, it certainly punches above its weight. The type of performance you can get on a typical survey operation, you should see on your screen now a kind of typical survey type trajectory, sort of motoring out to site, a point of interest, maybe doing a multi-beam survey or something like that, and then navigating back to base. And on these kinds of runs from the Sprint Nav Mini Navigator, you can expect to see a navigation of error of only 0.05% of the distance traveled. So that would be about 50 centimeters over a kilometer on a typical survey mission, which is, again, very, very high performance. So in terms of the Sprint Nav Mini, we've really also focused on trying to make it very easy to set up, to operate, to quickly view what's happening. So we've got an embedded browser interface on board, and what we'll do, that should come up on the screen in a minute, and I'll talk you through some of the key features. So the first screen you'll see is a simple dashboard display. So this allows folks to come in very, very quickly, see the status of the main points on the Sprint Nav Mini, like the navigation, the aiding sensors, things like that. If you want to drill in a bit deeper, you can go to the data view, and you can start to see some statistics in terms of the navigation, the quality, things like that. You can also have a deeper dive into some of the aiding inputs, like your GPS or other sensors like that. And then the last feature we'd like to show you is quite a neat little addition, which is actually an onboard chart that allows users to visualize what the Sprint Nav Mini navigation is doing with respect to the external aiding. In this case, it's GPS. And you can also very, very quickly see the expected navigation quality in terms of an aerolit plotted there, as well as the orientation, the heading, which way it's pointing. So a very neat little embedded web UI. It means you don't have to use external software to connect to the unit, and just makes it much, much easier to use. So again, sort of jumping back and reminding why you'd consider using a SprintNav Mini on a USV. As I mentioned earlier, a lot of them do undertake multi-beam surveys in shallow waters, but in many occasions, the GNSS that's used to particularly position these kind of vehicles, or maybe feeds to another INS on board, there are situations where that GNSS or GPS quality could drop. For instance, operating very, very close to wind turbines, maybe maneuvering very, very close to a launching mothership during launch or recovery. Also thinking about even closer to shore in harbors or rivers, places where there might be bridges. Again, sort of moving behind those kind of blockages or underneath bridges could mean there's loss of sight to the GNSS constellation. And SprintNav and SprintNav Mini, with its ability to track relative to the seabed, means that you will not see a degradation in quality of the navigation for those periods where you lose GPS. You can carry on going, your multi-beam is still compensated, and you don't get those kinds of errors. And of course, it will also cover things like if you see errors creeping in from loss of GNSS corrections as well. And also just another reminder that whilst the real-time performance is pretty seamless, you can further improve it on both versions by using our post-processing software after the event, post-mission. So with that, I think Aidan's going to join us because we've got some more questions coming in. So hopefully we can answer them for you.
Thanks very much, Malik. Yeah, a few more questions coming in, and we're going to just ask about 3 questions in this session. We'll carry over some until the end as well. So don't worry if the question doesn't get answered now, we will get to it. First question, Malik, is what's the maximum altitude that can be supported with a SprintNav Mini?
Yeah, so the SprintNav Mini has a maximum altitude of 200 meters, which given its size and the accuracy it can achieve is pretty class leading. Most DVLs that can achieve that kind of accuracy are much wider. So yeah, very, very class leading.
Great, and can I still interface GPS to SprintNav for when GPS is available?
Yeah, absolutely. Yeah, you can effectively treat SprintNav as or SprintNav Mini as a high performance GNSS INS, and then you have that addition of the DVL seabed relative aiding for when GPS isn't available or the quality drops. And you can easily configure the units to reject the GPS or GNSS if, for instance, aiding corrections are lost, and the INS itself will reject it if there are big jumps, for instance, if you went under a bridge or something like that.
And just one more for now, Malik, but do keep the questions coming in, and so we've got some time at the end for more questions for both Malik and John. Do both the SprintNav and the Mini SprintNav support NTP timesync?
Unfortunately not, no. The SprintNav supports PTP, which is a much more accurate Ethernet-based time synchronization method. And both of them support the sort of more commonly used ZDA from a GNSS receiver and 1PPS. So we'll continue to speak with customers and ask about, requirement for support of NTP. But at the moment, we see the most common use being 1PPS and ZDA. But there is the option of PTP on the full-size SprintNav there.
Great, thanks, Malik. So more questions towards the end of the session, but now we're going to hand back over to John.
That's great. Thanks, Aidan. So another thing that I'm quite interested in at Sonodyne is ADCP. And Malik has spoken to you about how we kind of integrate those instruments into the SprintNav. So it's the pressure sensor at the top, you've got the really high accurate IMU in the middle, and then you've got the DVL at the bottom. Something that's really exciting that Sonodyne have started doing recently is that DVL can now also become an ADCP. Okay, so the 600 kilohertz DVL that Malik spoke about earlier, that can also do ADCP down to a profiling range of 80 meters, and the 400 kilohertz DVL, which is a range or bottom tracking range of 210 meters, can also do an ADCP range of 120 meters as well. So that's kind of, if you want to do traditional ADCP, you can do that with a SprintNav or a Syrinx ADCP. But what I think is really exciting is that because we've got those really high accuracy positioning systems in the SprintNav, we can now use that SprintNav and those derived velocities and that derived position to both correct and georeference any ADCP data that we collect. And the really important thing there is that all those kind of positioning accuracies that Malik spoke about earlier, so kind of 50 centimeters after a kilometer, you could have done a whole kilometer of vessel mounted ADCP survey, and you've only got 50 centimeters of positioning error in that survey if you had no GPS, and the chance of having no GPS for a kilometer of ADCP survey are incredibly low. I think what's more important is that all the positioning accuracies that we derive from the ADCP, or sorry, from the sprint nav, they all ultimately come from how accurately we can measure velocity and calculate the velocity of the sprint nav and the vehicle or the USV that's it's mounted to. If we can calculate that velocity really accurately, we can also use that velocity to accurately correct that ADCP data. So you're getting possibly the most accurate vessel-mounted ADCP data that you can get. And also because we do an alternate ping pong between DVL and ADCP, you're not impacting the derived kind of navigation quality of the sprint nav. So if you're using that sprint nav to provide feed position and motion to a multi-beam, the fact that you're collecting ADCP in alternate pings is not going to affect that multi-beam quality. And also the fact that you're doing multi-beam is not going to affect the quality of the ADCP in terms of the velocities that you're collecting. The other great thing there is that because you're doing DVL then ADCP, you're collecting that ADCP data for free. So if you do want to have an extra deliverable or use your ADCP data for something else, as part of this kind of big data that's a real buzzword at the moment, then you're welcome to collect that data as well. Also, one of the great things about Sprint Nav ADCP that we're seeing a lot of is the fact that all that correction happens in real time. It's just a massive save in both post-processing and any data manipulation that you might need to do normally after the fact for a complicated vessel-mounted ADCP survey. But that's enough kind of, I think, just talking about ADCP. What I've got now is our software, which is Echo Observer. So Echo Observer is both for replaying ADCP data and viewing ADCP data in real time. So what I've got on screen here is that we're using our log replayer functionality in Echo Observer. And what I've got is some data from the Falls of Moura on the west coast of Scotland. We were up there in January this year actually on a manned vessel, and we were collecting data with the 400 kilohertz Syrinx ADCP on a 400 kilohertz sprint nav. And we were doing these kind of transects from north to south across this really high current area. If you see any colors down here in kind of yellow or red, that means we're approaching 1.5, 2.2 meters per second. And anything slower than that is kind of being dark blue down to 0 meters per second. So you can see as I go through this data, we're going to start building up a real theme, which is slow current in the north and high current in the south. And down at the bottom, you can see we're building up currents in the order of 2.2 meters per second. So this would be exactly the kind of place that you might want to work in USV. So you've got currents above 2 meters per second. You wouldn't want to put a manned vessel necessarily out there in harm's way. It's also the kind of place that you might want to come back and repeatedly survey for like maybe deploying a tidal turbine or something that's a really kind of edge industry at the moment. So yeah, that's the kind of full kind of data, and you can see in there we've got some of those really high color or high velocity areas up over 2 meters per second. So that's if you want ADCP data corrected and collected on the vessel. I'm just going to load another data set, which I think is also really interesting. So this is a piece of data on harbour entry. And I think what this really illustrates is a new use case for ADCP. So as I mentioned earlier, we're finally kind of getting used to USVs deploying and recovering vehicles. Normally on a manned vessel, you'd be very accurately monitoring the current with DP or maybe tide tables, both of which are, from personal experience, are pretty inaccurate. And if you're deploying an ROV, you really want to know exactly what the water column is doing beneath that vessel, so you know that your ROV is always safe when it's operating. Or if you're operating a wind farm, you know exactly when you're within the limits to maximize your efficiency in that area of operation. So if we click on this plot here, this is exactly the same kind of plot that you could see in real time if we were connected to a live ADCP. Down in the bottom right-hand corner, we've got the data overview screen. And you can see there that we've got kind of 0.2, 0.3 meters per second of current. So pretty much every AUV, every ROV in the world can deal with that kind of current. They have no problem operating there. But what we have got is these really interesting kind of hotspots near the seabed. They're spiking up to kind of 2.5 meters per second in some areas, 2 meters per second. And that's in both northing and easting, so a real big variation in magnitude of those currents. And that would mean that, okay, your ROV is safe for the first 8 meters, but then it might get into real trouble at the seabed. And it's worth mentioning here that we've probably got a 9-meter water depth, but with that 400 kilohertz ADCP on the 400 kilohertz sprint nav, you could be collecting this same ADCP data down to 120 meters. So you have really good real-time information about when it's safe to deploy those vehicles. So that's Syrink's ADCP. If you've got any questions about that, put them in the chat at the end, and I'm more than happy to answer them. And that's kind of summing up how we've integrated the instruments to get really good ADCP out of it. But now Malik's going to talk a little bit about how we can integrate multiple instruments, sprint navs, acoustics, into a USV.
Great, thanks, John. So hopefully you're getting a feel for the kinds of capabilities that the Sonodyne products can bring to your USV. We've talked about positioning, communication, also navigation and guidance. Well, if we bring those together onto one vehicle, there's obviously a lot of benefits that can be had, particularly if they're integrated. It means, we can position subsea vehicles, we can communicate with them from our USV, we can navigate the vehicle in a GNSS denied environment, we can compensate for onboard sensors, multi-beam, also actually compensating for the motion of our USBL with a high performance INS, which obviously we have here, as well as collecting other sensor data like ADCP. So a lot of things can come together into an integrated suite, providing a lot of capability for your USVs. And with their Armada fleet, this is exactly what Ocean Infinity have decided to do. With their fleet of vehicles, they've fitted out the USVs with both Ranger 2 USBL and our Sprint Nav, again to provide those kind of tracking positioning capabilities, even if there are periods of GNSS outages. And then furthermore, working with our sister company, IVA, there's a suite of survey software products on board that integrate to other survey sensors as well as our own sensors. They're all integrated onto that survey suite on board that provides onboard processing without the need for the data to go on shore, mission planning, execution, and quality control. Again, mostly on board, but with a low bandwidth link back to Ocean Infinity's Armada control centers onshore. So tying together all the products to give a lot more than the sum of their parts. So thinking about sort of more on the mechanical side of the integration, something that we also can provide, we're working with our industry partners or even just us directly, is provide tight mechanical integration. So you'll see on the bottom of your screen on the bottom left, there's an assembly there where we provided a pre-calibrated Sprint Nav and USBL system that can just be integrated directly onto a USV or a payload gondola. The other thing we can be working with our industry partners is actually provide a pre-fitted out gondola itself, both containing our instruments, but also third-party instruments as well. So there's quite a few options there in terms of mechanical integration and what we can do. And one of the last things that I want to leave you with in terms of trying to make the integration as seamless and easy as possible is that we've actually started to make more of our integration material publicly available. So for instance, if you go onto our website and you look at, for instance, our Sprint Nav Mini Navigator, if you scroll down sort of towards the bottom where there's some links for downloadable material, support material, and click on there, it will take you to our external GitHub repository. And you'll find some code samples in there like the one here that will allow you to just take the code that we've already written from there, integrate it onto your vehicle, that will actually decode the output from the Sprint Nav Mini Navigator without you having to write the code. So that's just one example. We're going to be adding more of these as we go, adding things like ROS drivers particularly for more products. So please do keep coming back to our website for products that interest you. Check out the product pages and check out what information and links and downloadable materials there to make your integration even easier. So with that's the end of myself and John presenting. So we're just going to finish off with our last Q&A session. So Aidan and John will join me and we'll try to answer any of the last questions before we finish up.
Thanks very much, Malik, and thanks, John, as well. Just got a few questions to follow up on now as well. We did have one about the cost of Sprint Nav Mini. What I will say about that is if you can get in touch with myself, I'm on LinkedIn, or email me, or the regional offices. I'm sure anyone there will be able to help you and have a conversation about that. Okay, so we'll cover that separately. Malik, first one is to you. Does Sprint Nav come with or interface with any particular station keeping or navigate by target on sonar or camera from UUV?
Sure. Well, I mean, first of all, we at Sonar, we have a lot of experience with interfacing to station keeping systems, both on large vessel DP and also autonomous platforms, subsea vehicle station keeping, things like that. So, you know, depending on the vehicle, our applications engineering team can work with you to get that interface going. In terms of using things like sonar or camera imaging, we do actually have on board the SprintNav family a SLAM engine. That's simultaneous localization and mapping. Some of you may be aware, and we may cover it a bit tomorrow on our RV and AUV session, that we can position with respect to a single seabed beacon. And that kind of engine can be used to take other aiming inputs from sonar and camera. But as it's fairly bespoke, we just welcome the conversation. So please do get in touch with us. We'd be interested to hear about the application you have in mind, and we can see if we can support that.
One for John as well. Can you interface with third-party survey sensors on your USV payloads?
Yeah, absolutely. So basically every piece of hardware that Sonar produces will eventually get interfaced to a third-party payload. So one of the big things you've got to think of when you're doing any kind of acoustics is how does that acoustics interfere with other acoustics? And we've got lots of experience in that at Sonar, so all of our hardware will come with triggers, so you can make all your devices either ping at the same time or ping alternately. And also we can help a lot with kind of mechanical separation of those devices as well. So yeah, if you've got a kind of problem like that, or you want a solution for an integrated payload, it's just fire us over what you want and we can have a conversation.
Great stuff. No, thank you both. I think that's the end of the questions that we've had come in. But if you do have questions that you want to ask us outside of the webinar session, please do get in touch with us. And say you can find us on LinkedIn or drop us an email or get in touch with the regional office. So yeah, I think that brings us to the end of this session. Thanks to Malik and to John. As I said already, do get in touch with us through the regional office or through the website sonodyne.com. I want to say thank you once again to the National Oceanography Centre for allowing us to host this webinar here today. We've had 2 sessions today, so yeah, it's been great to be able to use this fantastic backdrop for that. We also have our AUV and ROV sessions running tomorrow. If you haven't registered for those yet, then please do. You can do that online through the events page. Just while we're here, I thought it'd be worth promoting the fact that we're at Ocean Business, again, back at the NOC next month, 12th to the 14th of October. And we will have live dockside demonstrations of Sonodyne kit on both a USV, like this hydroserve vehicle here, and a UUV. And also both Malik and I will be in the autonomy session of the Ocean Business Conference, and we'll have a stand, obviously, at the show as well, stand E1. So I just want to thank you once again for joining us. I hope to see you in person, maybe at Ocean Business or at future webinars. Thank you very much.
Thank you.
Thank you.